So, in the last couple of sections, we talked about polynomial functions and talked about x-intercepts, directions of end behavior, that sort of thing. In the next couple sections, what we're going to do is we're going to focus in on what's called rational functions. And rational functions have to do with this kind of format, meaning rational, meaning like fractions basically. And this is a parent graph. So that sheet that I gave you guys before, this would be the parent graph of a rational function. And you can see by the equation on the left, it's 1 over x. There's no adding, subtracting, multiplying, nothing. And so this is the parent graph. And there's a couple things that we should kind of note about this. We should note, we see an asymptote right here. And that asymptote going horizontally is y equals 0. And if we go vertical, there's one vertically at x equals 0. So it has two asymptotes. Now, if we go to the next one, you'll notice that the degree on the top is 1 and the degree on the bottom is 2. And you'll notice there's some shifting. This moved to the right, still has a vertical asymptote, but that's shifted. And the horizontal asymptote is still at 0. So again, when the degree is bigger in the denominator. We're going to look at 1 where it's the same in the numerator and the denominator. Both of them have a degree of 2. Sorry, let's actually go down to this one. You'll notice there's 2 shifts. The horizontal went up, you can see that, and the vertical shifted as well. Some weird things happen when the degree is higher in the numerator. You can see a vertical asymptote, but this is called a slant asymptote. Now, every once in a while, there's some kind of weird things that happen, but those won't happen too often, and we'll kind of talk about that later, where we'll see an asymptote, but it's continuous. You guys see how this is continuous? Where this one has 2 sections, so it's not continuous. And same with this one, right? 2 different parts. So let's actually look at the notes. Okay, rational function. You have the numerator part. Okay, see this? We have that numerator, and then we have the denominator. So 3 different things happen we kind of talked about. And we want to know the differences. And again, the faster we know this, the better. When the degree of the numerator is less than the degree of the denominator, so again, denominator is higher, there will be a horizontal asymptote at y equals 0. So what is that going to look like? In the example, we kind of saw this on the Desmos, x minus 2, x squared minus 9. And if we compare the degrees, the top one has a degree of 1 and the bottom has a degree of 2. So again, higher in the denominator, horizontal asymptote at 0. If the degrees are the same, it is the ratio of the leading coefficients, meaning a over b. So if you have something like this, 8x squared minus 1 over 2x squared plus x minus 3, and you kind of take a look at this, hopefully you see that the degrees are the same. Okay, so if the degrees are the same, what you're going to do is you're going to look for the leading coefficient, and you're going to take that, take the ratio, and then the horizontal asymptote would be y equals 4. Now, if the degree is higher than the numerator, if the degree of the numerator is higher than the degree of the denominator, it does not have a horizontal asymptote. Instead, it will have something called a slant asymptote if it's exactly 1 higher. So if we look at this one, you can take a look at the degrees. This is 2, this is 1. The numerator is exactly 1 higher than the other one, and so you would get a slant asymptote, basically a diagonal. And it's kind of interesting how we can figure this out. You would actually use long division And if someone can remind me to do synthetic division in class, I'll show you how to do that. It's a much faster way. But if you remember long division, x goes into x squared once. Then you multiply it here. So x squared minus 2x. Then you subtract. Those are going to cancel out. You get negative 3x. Drop down the 4. And then x goes into negative 3x, negative 3 times. Multiply that by the outside. And then we're going to subtract. And what we're going to end up getting is those cancel out, and we get negative 2. And remember, this is your remainder. We kind of disregard the remainder, though, on the slant asymptote. So the slant asymptote would be at x minus 3. So again, we want to know 3 things. Is the denominator greater? Are they equal, or is the numerator greater? And those will account for 3 different things. Again, when the denominator is higher, horizontal asymptote at 0. If they're the same, it's the ratio of the coefficients. If the numerator is higher, it's going to lead to a slant asymptote, what we see here with long division. So question number 1 just simply asks, find the horizontal asymptotes, and then give a reason. Well, if we look at this one, the degree is higher in the denominator, so the horizontal asymptote is 0. So again, denominator degree higher than the numerator degree. All right, so then B. If we look at the degrees, they are both the same. If they're both the same, so the denominator degree, if I can use the right letters, the denominator degree is equal to the numerator degree. If that happens, then it means it's a ratio, and it's y equals 3 over 1, or just y equals 3. Now in this case, the numerator degree is greater than the denominator degree. So this would imply a slant asymptote. They don't actually ask us to calculate it, but what that would mean is that there is no horizontal asymptote. In number 2, they specifically ask for the slant asymptote. So for that to happen, the numerator degree has to be greater than the denominator degree. So we can see in both of those cases that is true. So if that happens, you are going to set up a long division problem. So we're going to put the denominator on the outside. And we're going to start the long division process. So when we go to do this, we're going to take the leading coefficient of both of them and divide it. So 2x cubed, that should be a 2, divided by x squared, that gives us 2x. And remember, that goes in the numerator. Or, I'm sorry, above here is the divisor. And then we're going to multiply it out here, and we're going to get 2x cubed minus 4x squared plus 4x. When we go to do this, we have to subtract everything. So that cancels out. This becomes a 7x squared, and then this actually becomes a negative 8x plus 1. And then you're going to kind of repeat that process. I'm going to take the 7x squared now, divided by x squared, and you're going to get 7. And then we're going to multiply that by the outside. 7x squared minus 14x plus 14. And then we're going to go ahead and subtract. That's going to cancel out. This is 6x, and that's minus 13. This is considered the remainder. We ignore that, remember? And the slant asymptote for this occurs at 2x plus 7. All right, pause the video. Go ahead and set up letter B and see if you can do the long division by yourself. Okay, and hopefully you got 3x minus 1 is the slant asymptote. And you can kind of see the work there, see if it matches up yours.